Hello and welcome. Today, we're diving deep into a topic that's not just the future, it's the now: artificial intelligence. This is a technology that is already reshaping our world in ways we're just beginning to wrap our heads around. So, let's start with a bit of a riddle. What do you think connects a car that drives itself, a computer program that can beat the best Go player on the planet, and an algorithm that can diagnose a disease? I mean, they seem like they're from totally different worlds, right? But they all share the same revolutionary engine. First up, let's talk about those robotic vehicles. And this isn't some far-off sci-fi dream. We're talking about cars that have already driven millions of miles on our actual public roads, often with a safety record that's, frankly, better than most humans. To do that, they have to constantly perceive the world, predict what's going to happen next, and act, all in real time. Then you've got the world of games. For literally centuries, games like chess and especially Go were seen as the absolute peak of human strategic thinking. But then a system like AlphaZero comes along. It taught itself how to play, and in the process, it didn't just beat the best human champions. It came up with strategies that no human had ever even thought of before.
And what about medicine? Well, AI is now looking at medical scans, things like diabetic eye disease or skin cancer, and it's spotting the signs with an accuracy that can match or sometimes even beat the most experienced doctors. So, what's the connection? Well, you've probably guessed it. The common thread tying all of these incredible feats together is, of course, artificial intelligence.
Okay, so how do we make sense of this massive topic? Well, here's our game plan. First, we're going to tackle the big one. What do we even mean by intelligence? Then we'll take a trip back in time to see the wild history of AI. After that, we'll explore the tools that are powering today's AI revolution. And finally, we'll look to the future and grapple with the huge questions this technology is forcing all of us to ask. You see, before you can even begin to build an artificial intelligence, you have to stop and ask a much more fundamental question. What is intelligence in the first place? And it turns out that's a really tricky question. The field of AI has basically come up with 4 different ways to think about it. The best way to understand these approaches is to map them out on 2 different scales. First, you've got the process. Are we trying to copy the way humans think, or do we just care about the final action? And second, there's the standard of success, or fidelity. Is our goal to be just like a human, or is it to be perfectly logically rational? This little framework gives us 4 really distinct goals for what we're trying to build. All right, first up is acting humanly. This is where the legendary Turing test lives. The whole point here isn't to figure out if the machine really understands or thinks like us. Nope. The only thing that matters is if it can fool a person into thinking it's human. It's the ultimate imitation game. It's all about the conformance. Next, we have thinking humanly. Now, with this approach, we absolutely care about what's going on under the hood. The goal isn't just to get the right answer, it's to get the right answer in the same way a person would. We want to see the same reasoning steps, the same mistakes, the same insights. It's really about building a true simulation of the human mind. Our third approach is thinking rationally. And this one kind of leaves the messy, unpredictable human brain behind and heads straight for the clean, perfect world of pure logic. This is the laws of thought school, going all the way back to Aristotle. The idea here is to build a system that uses formal logic to prove things step by step and arrive at conclusions that are absolutely, undeniably correct. And that brings us to the fourth and final box: acting rationally. This approach has a really elegant definition of intelligence. It's just doing the right thing to get the best result. An AI built this way doesn't need to think like a human, and it doesn't need to use formal logic. It just needs to be effective. And this right here, this is the big one. This flexible, goal-driven approach is the foundation for almost all of the incredible AI we see in the world today. Now, the path to where we are today was anything but a straight line. The history of AI is this incredible story of huge optimism, followed by crushing disappointments, and then these amazing triumphant comebacks. Just look at this timeline. It all kicks off in 1956 at the famous Dartmouth workshop. But that initial excitement slammed into a wall called the combinatorial explosion. Basically, problems got exponentially harder with every new step. That led to the first AI winter, where funding totally dried up. But the field clawed its way back with something called expert systems. Then, in the 80s, brain-inspired neural networks made a huge comeback, which set the stage perfectly for the deep learning revolution that kicked off around 2011. And that's the wave we're still riding today. And if you want to get a sense of just how optimistic those early pioneers were, you have to hear this quote from Herbert Simon. Right after creating one of the very first AI programs, he said this. He wasn't just saying he built a cool program. He was claiming to have solved one of the oldest problems in all of philosophy. The ambition was just off the charts. So that brings us to today. What are the core concepts that are really driving AI right now? Well, it's super important to get a handle on a few key terms that people often throw around as if they're the same thing, but they're really not. I want you to think about it like a set of those Russian nesting dolls. The biggest, outermost doll is artificial intelligence itself, the whole grand project. You open that up, and inside you find machine learning. This is a specific way to do AI where, instead of writing rules by hand, you just feed the system a ton of data and let it figure out the patterns for itself. Then you open that doll, and inside you find deep learning, which is a super powerful kind of machine learning that uses these complex, brain-inspired networks to find subtle patterns in truly massive datasets. And this new way of doing things has led to an absolute explosion. I mean, just look at this chart. Back in 2010, you had about 1,000 AI research papers published. Fast forward to 2019, and that number is 20,000. That's a 20-fold increase in less than a decade. This isn't just steady progress, this is a full-blown paradigm shift, and it's almost entirely driven by the success of machine learning.
Of course, with this kind of incredible power and mind-boggling growth comes enormous responsibility. We are right now at a point in history where we have to think very carefully about the benefits, the risks, and the path forward for this technology.
Now, the potential benefits are almost unimaginable, from curing diseases to tackling climate change. But the risks are just as real and just as profound. We have to confront the challenges of autonomous weapons, mass surveillance, algorithms that make biased decisions, and major disruptions to jobs. And these aren't some distant science fiction problems. These are active debates and challenges we're facing today. This quote from Norbert Wiener, one of the pioneers of cybernetics, just nails the central challenge perfectly. As we build these incredibly powerful systems, it's not enough to make them smart. We have to be absolutely sure that the goal we give them is the goal we actually want. This idea is often called the King Midas problem. Remember the myth? Midas wished for everything he touched to turn to gold. He got exactly what he asked for, and then starved to death when his food and water turned to metal. The lesson for AI is terrifyingly clear. If you give a powerful system a poorly thought-out goal, it might achieve that goal literally and cause a catastrophe. We need machines that don't just achieve their objectives, but understand and achieve our objective. So here's the bottom line. AI is here. Its power is growing at an incredible rate, and this is going to be a defining technology for our future. The conversation is no longer about if this is going to happen. The real question, the most important question of our time, is how are we going to build it? Because the answer to that will shape the next chapter of human history.